linearization. As I mentioned a little bit last time, if this is a function and this is 1, very close left and right, like 0.9, 0.95, 0.95, 1.01, 1.11, these values can be approximated, the function can be approximated with the tangent at P. And what is the equation of the tangent at P? So that's what, so this is the tangent at P. The linearization is denoted by L of x. This is the notation for the linearization. In other words, this function can be approximated by this tangent very close left and right of 1. If you want at x equals 3, then you have to determine a different function, a different linear function, a different linearization for that point. So for this point, L of x is just the same thing, f of x plus f prime of x and x minus this value, whatever it is, a. Actually, I have to use a everywhere here. So what does this mean? Exactly the same formula. Where's my formula? This is the approximate. So this is the f of x, and this is the f prime of x, and this is the minor error between 1 and any number nearby. So these are exactly the same. So I think I have 1 minute left. So I just want to show, and we don't have to finish it out. I just want to illustrate linearization. I don't know, do I still have a minute? I don't want to hold you. I have 2 minutes. Okay, good, excellent. So let's choose. Since you are fond of e to the x, find the linearization, which is denoted by L of x, of f, which is this, at a equals 2. So, let's say that was problem 23, f of x equals e to the x, and we have a equals 2. All we need to do is just write the formula. L of x equals f of 2 plus f prime of 2, and here it's x minus 2. It will be a linear function. This is a linear function. So we will find a linear function. So this will be f of 2 is e squared. F prime of 2, as we know, f prime of x is also e to the x, plus e squared x minus 2. And I will just distribute e squared times x plus e squared and minus 2e squared. And this is negative e squared. So e squared times x plus, I'm sorry, I meant to write negative, minus e squared. That's it. What does this mean? This is the line that approximates this function near 2. Very close. 1.9, 2.1, 2.2. So if you want to approximate this function at 2.01, you can use this. For e to the x, you may say, well, this is still difficult. But for other functions, this will be also a line, much easier to work with than the given function. What's the scope of this? Because we learned that the function can be approximated by a linear function, which is the tangent at that point, close to whatever point we want. This was 1. Here we were given 2.